Hi friends, let's begin our journey into the second part of second module where we are looking at various machine learning algorithms. So let's formally introduce what an algorithm is. An algorithm is a procedure or a set of steps or rules to accomplish a task. It is the basis of design of elegant and efficient code, data presentation, data preparation and processing, and software engineering. An algorithm can solve or sorting, searching, and graph based computational problems. Efficient algorithms that work sequentially or in parallel are the basis of pipelines to process and prepare data. So, about the machine learning algorithms. So, they are used to predict, classify, or cluster the results. The statistical modeling came from the statistics department. Machine learning algorithms came out of computer science departments. They are the basis of artificial intelligence. Let's see the difference between the statistical and machine learning algorithms. So first let us look at interpreting the parameters. The statistical algorithms have real world interpretations about the parameters, but in machine learning these parameters are unknown, so we have a black box approach. Talking about the confidence intervals, the statistical algorithms provide confidence intervals and posterior distributions for parameters and estimators and are interested in capturing the variability or uncertainty of the parameters. Whereas the machine learning, no such thing exists, so there is no notion of confidence interval or any uncertainty. The role of explicit assumptions in the statistical model, they make explicit assumptions about data generating processes and distributions. So here we do assume that the data is coming from a system with a particular distribution, and we use this data to estimate the parameters. Whereas the non-parametric solutions, like we see in this chapter, do not make any assumptions about the probability distributions, and they are implicit in nature. Now, coming to the machine learning techniques, basically there are three types of machine learning techniques. One is supervised, other unsupervised, and third we have reinforcement learning. In supervised learning, it involves training a model on a labeled data set. Here, each example in the data set is paired with an associated label or the output. So, for every data, we know to which class or what the output is supposed to be. And once the model is trained, this model can make predictions on new and unseen data. So, looking at the supervised learning technique, we have labeled data, that means pairs of input output, and then we have a training phase where the algorithm adjusts its internal parameters or the model structures to minimize the difference between the predicted output and the true labels of the training data. So here a model is assumed, and in this the internal parameters are used to predict the output, and if the output is not matching with the real output, then these internal parameters are adjusted so that the predicted output will match with the real output. Once this training phase is done, we evaluate the model by testing with a new set of data whose output is known to us, but that will not be presented to the model, and the predicted output is compared with the actual output, and metrics like accuracy, precision, recall, F1 score, mean squared error, etc. are computed to know how better the model is behaving. And lastly, we use this model for future predictions. It can be used to make predictions on new unseen data. So there are two categories of supervised learning. One is called regression, where the output is of continuous numerical value, and the other one is classification. Here the output belongs to a discrete class, label, or category. So various supervised learning algorithms are, for example, linear regression, logistic regression, decision trees, random forest, support vector machines, neural networks. Now coming to the second part, that is unsupervised learning. Here the algorithm learns from unlabeled data. In the supervised learning, the data was labeled. That means for every data, what the output should be was given. Whereas when the data doesn't come with any labeled data, then this algorithms comes to our aid. In this case, the training dataset does not have any corresponding target variables. The goal of unsupervised learning is to uncover hidden parameters, structures, or relationships within the data without explicit guidance or supervision. So we don't know to which category each data belongs to, but we only know that there exists data. So looking at the data, we try to understand the pattern hidden behind or any structures or relations within the data and try to learn from that. These algorithms explore the data to find the inherent structures or groupings, often used for exploratory data analysis, data pre-processing, feature extraction, and anomaly detection. So the types of unsupervised learning, it may be clustering. So it can be k-means clustering, hierarchical clustering, and density-based clustering, or it can be dimensionality reduction like principal component analysis and so on. So there are basically two types of supervised learning. One is clustering. The given data are clustered into some number of groups. Another case, data with a large number of features can be redefined to have a lesser number of features, so where there the dimensionality is reduced. And the third category is the reinforcement learning. Here an agent learns to make decision by interacting with an environment in order to maximize cumulative rewards. In this case, there is nothing like input. There is an environment, and the agent will make some attempts, and because of these attempts, either it will get a reward or a punishment, and depending on the activities, it in future tries to repeat those actions which give better rewards and tries to avoid the activities which give it punishments. So that is the basic concept of reinforcement learning. Here The reinforcement learning operates based on a system of rewards and punishments. The basic components of reinforcement learning: there is an agent, so it's a decision making entity that interacts with the environment. The agent takes actions based on the current state of environment. It's an external system or the domain with which the agent interacts. Agent responds to the actions taken by the agent. The environment responds to the actions taken by the agent and transitions to a new states accordingly. State. So when agent interacts with the environment, so the environment is changing. So this change in environment is represented by a state. So it's a representation of current situation or the configuration of the environment. The state provides information about the context in which the agent is operating. Action. There is a possible set of moves or decisions that agent can take in a given state. The actions lead to transitions to new states and potentially yield rewards. A reward scalar feedback system that indicates how good or bad agent action was in a given state. The goal of the reward is to make sure that the agent takes the actions more often for which it gets rewards or positive rewards, and tries to avoid those actions which gives negative rewards. So in all, reinforcement learning is an ultimate, it's almost the ultimate machine learning, where machine tries to imitate the overall learning pattern of a human, where human interacts with the environment, and through this environment there will be change in the environment, and these changes in the environment may give a positive result or a negative result. So the human tries to imitate more and more actions which give positive results and try to avoid which gives negative results. So in this way, with time, the human tries to correct himself and makes more and more positive actions, and will avoid as much as possible the negative actions. So this way the human learns. So we want our machine also to behave the same way, to learn on its own by interacting with the environment, not providing with the data and all that. So that's ultimate in machine learning, that's a reinforcement learning. So that's it for now. So let's see many more details in the coming sessions. So till then, keep watching. Thank you.